We're going to go over commonly missed things on RIP 2. Number 1, part B. If g of x is x squared minus 4x plus 5 and f of x is represented by this table, g of f of negative 2, we have to understand that f of x equals some value. So if I have f of negative 2, the negative 2 represents the x value. So that means f of negative 2 is going to equal whatever the x value is of f of x at that value. So that equals 5. So that means I'm going to replace f of negative 2 with 5. A lot of people had it backwards, thinking that this negative 2 represents f of negative 2. But no, this is the x value. So that is in this part of the table. This is the x value. So if we look at f of 6, that would be negative 2. So these represent the y values. And then after that, most people did pretty well, whatever they substituted in. But if you substituted 6 in here, or I'm sorry, if you thought that negative 2 gave you a y value of 6 and you had it kind of backwards, you would have got 17, but that's not the correct answer. So you have 5 squared minus 4 times 5 plus 5, which gets you 10. That should be the correct answer. Then h of g of x, most people did really well. So that's h of x squared minus 4x plus 5. And then you replace the x in h with this. So you have 3 times x squared minus 4x plus 5. The biggest issue that people had was forgetting the minus 2. So remember that h of x had the minus 2 in it. So we end up with 3x squared minus 12x plus 15 minus 2. So it ends up being plus 13. This problem gave us the most issues. In order to get an inverse function, f of x is the same thing as y. We have to flip the x and y. So x equals 4 y minus 5 cubed plus 7, and then solve for y. That means that we have to know the order of operations, and our order of operations was very poor in general on this problem. So let's look at what happens to this variable. The first thing that happens is what's in the parentheses. So the first thing is minus 5. Then the next thing is the y minus 5 gets cubed. Then we take the y minus 5 cubed and we multiply it by 4. Then we take all of this 4y minus 5 cubed, and we add 7. So in order to undo all of these things, we have to go in the reverse order. It's kind of like if you are a person and you put stuff on your feet, you put the socks on first, and then you put the shoes on top of that. Well, how do you undo that? You don't take the sock off first, you take the shoe off first, and then you take the sock off second. So we have to take these things off in the reverse order they get put on. So what we have to do first is subtract 7. So we're going to subtract the 7 over. Y minus 7 equals, or I'm sorry, x minus 7 equals 4 times y minus 5 cubed. So that undoes the plus 7. Then we divide by 4. So x minus 7 over 4 equals y minus 5 cubed. And I'm almost about to run into my stick figure. That gets rid of the 4s. Then, how do I get rid of cubed? I take the cubed root. So I take the cubed root of everything. That gets rid of the cubed, so y minus 5 equals the cubed root of x minus 7 over 4. Notice the 4 is inside of the root. It is not x minus 7 cubed root over 4, where the 4 is just kind of all by itself. That's not what's happening here, because we divided by 4 first, and then we take the cubed root of everything that's over there. So those cancel each other off. Then we add 5 to both sides. That cancels off the 5s, and we're left with the cubed root of x minus 7 over 4 plus 5. So how can I write this? I can write this as f inverse of x equals this, or I could also write it as, f inverse of x is equal to the cubed root of 1/4 x, or x over 4, minus 7 over 4 plus 5. Or I could realize that the 4s, actually I can't do that because it's a cubed root, not a square root. A couple people thought that this is not a function, but the cubed root function is a function with cubed, or as an opposite of the cubed function, because the cube function is 1 to 1. So when I take the inverse of it, it looks something like this. So there is no issue with the vertical or horizontal line test in either case. What was happening a lot, and I just want to touch on this really briefly, was that some people were doing things like y minus 5 cubed and taking the cubed and thinking that you can distribute the exponent. There is no such thing as the distributive property of exponents over multiplication. If you were going to distribute this, you would have to write y minus 5 times y minus 5 times y minus 5 and do a bunch of multiplying, and you'd end up with y cubed minus 25y squared, or I'm sorry, minus 5y squared plus 25y minus 125. And you don't really want to do that because then it makes it harder to solve for y. So this is not a good idea. You cannot distribute this. This is not allowed. And especially thinking that you can just make it y cubed minus 125. That is a total no-no. Cannot do that. It is not the same thing. When we were flipping the sign, or flipping the x and y, and we end up with 4 times the cube root, times x minus 5 cubed plus 7, I think it was. Yeah, so when we have this, a lot of people were like cube rooting everything here. That's not allowed. You can't do that because you would have to cube root the entire side. And you can't do that when it's all by itself. Like, you have to get that all by itself first in order to do that. So you cannot do this. You also cannot just think that we can like subtract 7 over and then take a cube root and ignore the 4 and keep that as like it's an all by itself 4. Those were the things that were happening a lot. In order to avoid these issues, make sure that you think about what happens to the variable and then undo them in the correct order, like in the opposite order of what it was.